This is your 7.4 homework. Again, I'm just going to show you how to do some of this stuff in your calculator rather than write out notes, just again due to timing of the left in this semester. So this is a section on inverses and matrix inverse and inverse operations with matrices. So when you have two matrices that are inverses, what happens is when you multiply them together, you end up getting the identity matrix. So I'm going to come in here and edit these matrices. These are both 2 by 2 matrices. So first of all, for it to be the inverse, it would have to be the same size. So we couldn't have like a 3 by 2 over there or something. And then after I do this, I'm going to show you two different ways to do it. One, again, multiply them together. And again, you don't have to multiply it with your calculator. If you understand how to multiply matrices from the last section, when I went over it briefly, you can simply just multiply it here and see if you get the identity matrix back. Alright, now again, if these two things are inverses, I would multiply A times B and get the identity matrix. I don't get the identity matrix, so they are not inverses. Alright, now another way that I could have known that they're not inverse matrices is there's an inverse button right here. X inverse is the inverse of whatever you put in. So if I put in matrix A and then I hit inverse, hit enter, press math 1, change to fractions, that doesn't look like matrix B. Okay, now it is a scalar multiple of matrix B, okay, but it is not matrix B. It's asking, is this the inverse? And it's not. It has to be exactly those numbers for it to be the inverse. Alright, with number 2, again, I'm going to multiply these two matrices together. So I'm going to put them in exactly how I see them. Alright, second, X inverse, to come into the matrix menu, go over to edit. These are both 3 by 3 matrices, and again, for a matrix to have an inverse, it has to be, these two numbers have to be the same. 3 by 3, or 4 by 4, 2 by 2. Only square matrices have inverses, so if you give a 2 by 3 or a 3 by 4 or something like that, it's not going to have an inverse. Alright, negative 6. I'm just going to put in both of these matrices. When you're ready to edit the second matrix, matrix B, notice that when you put these fractions in, negative 17/18, it's gonna, when you hit enter, immediately it's gonna change it to a decimal. Alright, and don't worry about that. Okay, so just let it give you a decimal, and just, you know, keep working with it. It's got the fractions stored in there, so it's not a big deal if it gives you decimals. Alright, again, all of them are decimals, no matter. Again, it'll store them in there as fractions. Alright, now we want to multiply matrix A times matrix B, and what do we get? Oops. And what do we get here? If they're inverses, we need to get the identity matrix, and they are. Okay, so 1's on the diagonal, 0's everywhere else. When that's the case, you have a matrix, or an inverse matrix. Now, Always check it the other way. B times A should also give you the identity matrix if these things are inverses of one another. Alright, again, it does as well. So when that's the case, you have inverse matrices. When they want you to find the inverse of a matrix, just pull this over a little bit so we can see both of them together. When they want you to find the inverse of a matrix, again, the process, if you click on help me solve this, there's a pretty straightforward formula for finding it. They have you augment with the identity matrix and then use row operations that were discussed at the beginning of chapter 7 to get the identity matrix over here, and then what's left over here ends up being your inverse. So they're going through and showing the process. There is your inverse matrix. Okay, now with time permitting, we would go through that when you'd have to do one or two of them by hand for me, but since we're running out of time here, go to your matrix menu, edit. Again, make sure you have the right dimensions in there. We need a 2 by 2 matrix, and then put the numbers in 4, 3, 2, 7. Alright, back out. A lot of times the inverses of matrices have fractions involved, so when you see decimals like this, press the math button and change it into a fraction. Always give me fractions, and always give your the MyMathLab fractions. So there's your answer. 7 20 seconds. Negative 3 20 seconds. Negative 1 11th and 2 11ths. Alright. So again, just make sure that you change it into a fraction. Don't put those decimals in there. Alright, don't round the decimals and put those in there. Change it to a fraction. Alright, same thing with a 3 by 3 matrix. Instead of, on the last one we had a 2 by 2. Alright, this one we got a 3 by 3. Notice my calculator had a 3 by 3 in there, so you don't have to edit the first one, just edit the 3 by 3 one. Alright, so 1, negative 1, 1, 0, 2, negative 1, 3, 2, 0. Alright, and call the matrix where you have, what you're using. We're using B this time, and then check and see if there is an inverse. Alright, it says A inverse, but you don't have to store it in A. You can store it wherever you want to. Alright, so there's our matrix. Alright, check the answer. Good job. Now, notice that every single one of these, the last couple anyway, have had this second. The inverse matrix does not exist. Okay, but these last two have had that. I want to give you example one that does not have an inverse. Alright, so here's a 3 by 3 matrix. 3, 1, 2, 1, negative 5, 6, negative 12, negative 4, negative 8. I've got that in my calculator here. Alright, if I back out and I tell it to find, I've got it stored as matrix B. So if I tell it to find the inverse of B, it says error singular matrix. Okay, meaning that this matrix is not invertible. And the problem here is this bottom row down here is a scalar of the top row. If I multiply this by negative 4, I get this. 1 times negative 4 is this. 2 times negative 4 is this. So this whole entire bottom row just results from multiplying the top row by negative 4. And if something like that happens, there's other things, that's not the only thing, but if there's something like that happens where elementary row combinations would give us a row of zeros, then we have what we call a determinant of 0, and we end up with a non-invertible matrix. So there is no matrix that I can multiply this matrix by and get the identity matrix back. So I just want to bring up that warning to you that if you see that, then the matrix you have is non-invertible. Alright, another type of problem. So they're giving you the inverse, and they want you to solve AX equals this for X. Now, the theory behind this is if I multiply a matrix, a matrix A times a variable matrix, and I get B, the way this works is if I multiply on both sides of this matrix equation, on the left by the inverse of A, okay, so what I want you to see here is this is what was there before. Alright, AX equals B, that was there before. We just multiplied both sides of something that was equal by the same matrix. Okay, now what happens here is, as we said at the beginning of this section, if you multiply a matrix times its inverse, you get back the identity matrix. And what happens when you multiply a matrix by the identity matrix? You just get that matrix back. Alright, so X that we're looking for equals A inverse times B. So that's what's going on in this problem. There's our AX equals, there's our B matrix. So to solve it for X, what am I telling you here? X equals A inverse times B. So that means for this problem, X equals A inverse times this negative 2, 5 matrix. Alright, so what we do, again, you can do it by hand if you're to the point where you're comfortable with that, but you can also put it in your calculator. This is going to be what we store as A. So even though it says A inverse, what you have to get yourself used to is, even though it says A inverse, and even though I told you A inverse times B, you need to enter this in as matrix A. So this is a 2 by 2 matrix. 11, negative 7, negative 3, 2. Alright, and then enter B in, or edit B. It's a 2 by 2, or sorry, a 2 by 1. Alright, enter it in as negative 2, 5. Alright, but even though I told you right here on this page to do A inverse times that, this is A inverse. What we stored as A is A inverse. So if I'm multiplying A inverse times B, since that is A inverse, I multiply that times matrix B. Alright, and I get negative 57 and 16. Okay, if I would have made the mistake of sticking that inverse in, I'm not going to get that at all. So make sure you're paying attention on a problem like that. If they're giving you the inverse matrix, you're going to have to multiply it by this other matrix to solve for X, because that's how it works. A inverse times B. A inverse times the matrix they give you. But you're going to store that in your calculator as A. So just remember not to put that inverse thing in there. Since we're calling the inverse of A, we're calling it A. So we just have to keep that straight when we're doing a problem like number 6. Alright, and then for several of these from here on out, here's your system. Go in there, edit both sides. This is a 3 by 3. The coefficient matrix is your left side. Right? So 1, 5, 5, 1, 4, 5, 1, 5, 4. Right? That's the XYZ coefficients, or what we call the coefficient matrix. And then your B matrix, in this case it's a 3 by 1. Your B matrix is a 3 by 1 because there's 3 rows with one thing in each row. Alright, and that gives me negative 40, negative 36, negative 35. Alright, and the way we do this is exactly what this thing says. A inverse times B. That's our X. This is a matrix. We call it X, but capital X represents the matrix XYZ. It represents our solution matrix. So when we solve A inverse times B, there's our X, there's our Y, there's our Z. So 5, negative 4, negative 5. Alright, problem number 11, coding. So this actually used to be used a whole lot, but not as much anymore with the advent of computers and computers' ability to come up with these themselves and come up with much more sophisticated crypting. But anyway, what I've done is I've already got, let me show you, I've got matrix A, right, as this matrix, the coding matrix. Okay, its inverse is this. Okay, so that's the inverse of A, so I don't need to use a separate space for that. I'm not going to store B as this inverse, but I do have B stored as this matrix. Okay, that's this phrase. Okay, now notice how they do it. WHO, that goes down here. So there's a WHO space AM space 90. Okay, so there's how that works. Now we're going to code it. So we're going to take our matrix and we're going to multiply it by this coding matrix, and that's going to give us our coded or encrypted message. Alright, so to do that we take our coded matrix, which is this first one A, and I'm going to multiply it by this matrix that we have our phrase stored in, B. Right, and there's our encoded message. So notice how we did this. This goes down this way. Alright, so we're going to do the exact same thing. 15, 99, negative 38. Alright, and then jump up negative 1, 26, negative 13, negative 9, a couple zeros. Alright, and then the way these work is that message would go to somebody. He or she would have this inverse, this decoding matrix, and they would take that coded A times B matrix that we got right here. Alright, they would note it right, this is the first column, this is the second column, this is the third column, and then they would take the decoding matrix, which is the inverse of matrix A. Again, they would already have it written down, and they would multiply that by the matrix that they got right here, and that would take them back to their original message. Okay, 23, 8, 15, 0, and that would then they would know 23, that's W, 8, that's H, and they would know which letters to use. Okay, so that's how that coding, decoding stuff works. Alright, so with this problem you're going to do, this is the next one, that you're going to do the exact same thing we just did there, except you are given the encoded message. Alright, so that's going to be a matrix. Alright, notice the encoding message is 3 by 3, so that means your message is going to be in threes. So we got 1, 2, 3, there's one column, 1, 2, 3, there's 2, 1, 2, 3, there's 3, 1, 2, 3, there's 4. So we have I'm going to call this one B, a 3 by 4. Alright, and we'll say 22, let's go down, negative 16, I'll just go ahead and put that in. Alright, so I've got matrix A in here. This is the encoding matrix. So 1, 2, negative 1, 2, 1, negative 3, negative 1, 4, 2. Alright, and I also have in that 3 by 4 I have matrix B, and there's the 22, negative 16, 83, 45, negative 4, 130, 37, 6, 85, 30, 11, 61. Now, when you're putting this in, when you're putting matrix B in, and you're having to go down, when you're putting in 22, negative 16, 83, notice when I put in 22, I hit enter, it goes to the right. So you're going to have to keep in mind that you need to go down to negative 16 and down to 83. Okay, it's a pain, you know, because that's the way we normally do matrices, left right, because usually it's an equation left right, but when we're doing this coding stuff, it's common to do them in columns like this. Alright, so what do we need to do? We need to use the inverse of this encoding matrix and multiply it by our message to get our message. So there's our message. So 7, 15, 15. 7 is G, 15 is OO. So that's GOO. Alright, 4 is D. Good. Alright, 27 they said is a blank space, so space. And then 13, 15. 13 is M. 15 is O. 18 is R. 14 N. 19 I'm assuming it's going to be I. 14 is N, and 7 is G. Okay, so that's how that works. The inverse of an encoding matrix is the decoding matrix, and to get back to the original matrix you have to multiply it on the left. Now notice, if I had multiplied this on the right by the inverse of matrix A, it's not going to like it because there's a mismatch. Okay, it's a 3 by 4 and a 4 by 3, or a 3 by 3, so you can't multiply those together. Okay, so you got to make sure you're doing it on the correct side, left side versus right side.